Hello, in this video we are going to talk about transformations of functions. So we're getting into a whole lot of graphing. You may want to have Desmos at the ready as you work through this video and through this section. Okay, so transformations of functions basically means we're taking that parent functions, those main functions we looked at earlier in this chapter, and we're using them to graph all kinds of functions that are similar, but maybe shifted around on the rectangular coordinate system. Okay, so we just want to understand, if I take one of those parent functions like x squared, and if I start throwing in numbers around it, like maybe I add a number to the end or add a number inside of the square, what does that do? What effect does it have on the graph of the function? Okay, so the first one is a vertical shift. If I take one of those original functions and then add a number to the end, any constant, if it's a positive number that I'm adding, it's going to take the whole graph and just shift it up. As you can see here, this is a cube root function, and here we're just adding one, and it just takes every point and just adds one to it. So it shifts everything up one spot. The shape stays exactly the same. If that number that I add to the end is negative, so I'm subtracting a number, then it will shift it down. Okay. If for a horizontal shift, I have to add it within the function. So for the cube root function that we're looking at right here, if I add a value inside of the cube root instead of to the end of the whole function, then that will cause a horizontal shift. Now, the tricky one about this is it goes in the opposite direction you would expect. With vertical, you add a number, it goes up. You subtract a number, it goes down. With a horizontal shift, it does the reverse. If you add a number, it goes to the left, which is not really what we'd expect. And if you subtract a number, it goes to the right. It shifts every point to the right. Something else that I can do is start throwing negatives in there, and this will cause a reflection. If I just throw a negative out in front of the entire function, I just take the whole thing and make it negative, then that will reflect it across the x-axis or cause a vertical reflection. So the reflection is just like a mirror. I get a mirror image on the other side of the x-axis. If you stick it within the operation, so thinking of that cube root function again, if I were to make it negative inside of the root instead of outside of the root, then that would be a reflection horizontally or across the y-axis. So it just flips everything and gives me a reflection on the y-axis there. Other things that we can do to manipulate one of those original functions is to compress or stretch them. And we do this by multiplying by a constant. If I multiply the whole function by a constant, and that constant is greater than 1, it stretches the function. And if it's a fraction between 0 and 1, it will compress the function. If I do this within the operation, so thinking back to that cube root again, if I'm throwing a number inside of the cube root instead of multiplying it out front, then the reverse happens. It stretches when the number is a fraction and compresses when the number is greater than 1. Now, there's a whole lot of transformations we just went through. Really, what I recommend doing is pulling up the Desmos app, picking a function, and start playing around with it. Multiply it by things, add and subtract things in different places, and see what happens to the function to really get a feel for how to manipulate these using these transformations of functions. Now, the last thing that we want to be able to identify is even and odd functions. Okay, so if I take and throw a negative within the function, so inside whatever operation, wherever the x is, and after simplification, I just get the original function again, then we call that an even function. And when I graph it, I can see that evenness in its symmetry. So on the bottom left here, I have the graph of y equals x squared. And you can see, right, if I just draw a line through it at the y-axis, I have a mirror image on each side. That's what we call symmetry for a graph. So this is symmetric about the y-axis, which means, well, if whether I plug in positive x or negative x, I will always get the same answer out, which you can also see here. Like if I plug in -2, I get 4. And if I plug in positive 2, I get 4. Okay, so that's what it means to be an even function. An odd one's a little bit trickier. With this, if I plug in a negative value, I get just the opposite sign of what I would have got had I plugged in the positive of that value. And this is seen in symmetry about the origin. And you can see symmetry about the origin by graphing the line y equals x. So that's what this dotted line here is. And this is a y cubed, a y to the third power function here, and it has this symmetry about the y-axis. Basically, if you take and rotate the whole thing, you should end up with the same graph. If you rotate it 180 degrees, you end up right back where you started with the same graph. Okay, so those are the kinds of symmetry that you might see in a graph, and that tells you whether a function is even or odd. Okay, so let's do some examples. So here I'm being asked to graph f of x equals x plus 3 squared minus 2. Okay, so if I'm graphing this by hand, if I want to do a sketch, the parent function here is coming from the square here. So my parent function is y equals x squared. The minus 2 at the end tells me that there's a vertical shift down, and the plus 3 tells me that there's a horizontal shift to the left. Now, to see all this, I'm going to pull up Desmos so we can play around with this and kind of see how that happens. So I'm going to start by just plugging in y equals x squared. There's my parent function before anything happens to it. Okay. If I take that function and I graph it again, and this time I'm going to subtract 2. And so there's my function, exact same thing, only everything is shifted down 2. Now I want to also do the horizontal shift. So I'm going to go plus 3. And now I can see, okay, it went down 2 and to the left 3. Finding some critical points like where it goes to the origin here is a great way to get that sketch. So I usually start with a sketch of the parent function and then do the shift. And so I get this one here. If I wanted to continue to play around with this just to experiment, I can say, okay, well, what happens if I put a negative on there? And oh, there I see how it did a reflection about the x-axis. What if I threw a number out front? Well, now it just compressed it from what it was before, or it shrunk everything down. Right? So I really recommend as you learn more about these transformations to just play around with adding and subtracting, multiplying numbers into the graph to see how it affects things. Okay, one more question for this video, and that is determining whether a function is even, odd, or it could be neither. Okay, if there's no symmetry, then it's not even or odd. Here I have f of x equals x to the 7th. Now there's a variety of ways that we can determine this. One, I could just start by plugging negative x into the function, simplifying, and see what happens. If I get the exact same function that I started with, x to the 7th, then that's an even function. If I get the opposite sign, it's an odd function. And if I get some weird combination of negatives and positives where it's not the same and it's not the opposite, then it's neither. So if I do that here, I plug in negative x to the 7th power. Now, because I'm raising it to an odd exponent, I know that I will have an odd number of negatives when I actually raise this. So this is the same thing as just doing negative and then x to the 7th. This tells me that it's odd. Now, this might be a little tricky for you to see by plugging in an x. So you can always plug in some real numbers. So maybe try -2. What happens when I plug that in? Do I get the same thing as I would if I had just plugged in 2? Or do I get the opposite or something else? Now here, if I plug in -2 to the 7th, well, I get the same thing as if I had just plugged in 2 to the 7th and made it negative. Okay, so this is an odd function. You can also graph it. So here's a picture of the graph of x to the 7th, and I also drew the line of y equals x because I'm suspecting that it's odd, and I can see I have that same symmetry going on about the origin that we had with x cubed. So, so this is definitely an odd function. Okay, so there are a couple examples below this video for you to practice these concepts some more.